Working with managed Kubernetes cluster is kind of a cup of tea or easy task when you are configuring it as a DevOps engineer or cloud engineer. When things comes to configure the Kubernetes cluster from scratch where you don't have any cloud setup or anything, and someone is giving you only EC2 instance or an idle virtual machine, and they're asking you to create or configure the Kubernetes cluster from scratch. So you might be thinking that how to do it, or if you have configured it, you have to do a lot of stuff. But after doing that, the main responsibility for the Kubernetes cluster should be high available. And at that moment, we used to think about cloud managed Kubernetes cluster, whether it can be AKS, EKS, or any other cloud provider. But what if your organization wants to set up their Kubernetes cluster in their on-prem data center? At that moment, you might not have the permissions to create the Kubernetes cluster from any cloud. And at that moment, you have to make your Kubernetes cluster more high available. And there things comes like multi-master nodes. So hi guys, my name is Aman. I hope you guys are doing well. And in today's video, I will be covering the same topic that I've discussed, that how to work with multi-master node, or you can say that how can we configure our Kubernetes cluster in that way where our Kubernetes cluster should be fault tolerant and high available. So this is one of the very important topic when you're giving interviews. An interviewer can ask you anything from the Kubernetes, and if you know that how to create a deployment or how to create a services, that is not a enough thing. As a Kubernetes developer or administrator, you need to know, you need to understand how to work with Kubernetes from scratch. So let's get started and head over to my screen, and let's add one more amazing stuff in our resume so we can showcase our important learning about Kubernetes stuff. It's not only deployment, or it's not only about ingress, or it's not about application deployment, because before deploying the application, the main thing is to configure the high available cluster as well. First of all, I would like to tell you that as we are going to create multi master node, and we will have also worker nodes, and one more thing that will help us to configure the multi master node. So for that we need multiple virtual machines, and I will be going to use AWS cloud for it. And don't worry that I am not going to create a EKS cluster from here. I'll just use EC2 machines, and we will be going to install each and everything from scratch. So you will be able to understand how to do that. That's why I'm using AWS. If you have Azure cloud or GCP cloud or any other clouds, you can also do that. There is no big issue with that. You just have to make sure about the few things, and apart from that everything is same. So before jumping on to the hands-on, the main thing that we need to understand what exactly we are going to do and what are the setup we have to do. So for that I will show you one infrastructure diagram, or can say architecture diagram, so you will be able to understand what are we exactly going to do. So I will just go to my draw.io, that is I used for my creating the architecture diagram, not those architecture diagram that I've created on LinkedIn. If you have seen my architecture diagrams, so those architecture I used to create by PowerPoint. So if you want me to cover those things as well, so I would happy to do that. Just let me know in the comment section. So I'll just click on create diagram, and let's take a blank diagram. So now we have the draw.io diagram, and we have the website open, and I'll just, so now first of all, as I've told you, we are going to use AWS cloud. So for that I'll just take one rectangular shape, and this would be our AWS cloud. Now what are the things that we need, like what types of EC2 instances we need and how many instances we need. So I will take a square shape which will refer as master. And as I've told you about multi-master node, so we will have three multi-master node. And why do we need it three instead of two? We can also have two. Behind this there is a science, or I can say there is a thing that quorum, which means minimum. If you have ever heard about quorum, So quorum's alternative word is minimum, and in that the minimum quorum should be in the odd number only. Either it can be 1 or 3 or 5 or 7. So whenever you are going to create a cluster of any tool like Kubernetes master node, or if you want to go with RabbitMQ cluster, or if you want to go with Redis cluster, any type of cluster, so I would suggest you to go with the odd numbers quorum, because that will help you to achieve the zero downtime. I will also tell you why I'm saying this and how does it work. I will show you that thing as well. But before that, let's understand the architecture first. So I'll tell you how to calculate the quorums as well. So this is my master one, and as I've told you that we will be going to use three master node. If you have your application big, or if you think that your cluster needs more master, so you can also go with more master nodes. So we will have master 2. I will just create the master 3 as well. And now we will create worker node. So I'll just drag it down. So I am going with simply 2 worker nodes. So I'll just create one more worker node. So we have 2 worker node and 3 master node. Now the thing is that, as you can see, there is no connectivity that I've added right now. So let's take an example of Nginx application. So let's suppose I want to deploy my Nginx application on worker node 1. So how can I do that? Like, I can simply run the kubectl apply command with Nginx deployment file or pod file, whatever you can say. So I can do that. But for that, the node should be connected with the master node, or master node should connected with worker node. Yes, as you can see that it's a very simple thing to run the join command when you use kubeadm command. So to join the worker node with the master nodes, it's very simple. But the point is, when you have three master nodes, you have to show them as one entity instead of three separate entity. So if you are keeping it separate, worker node would be confused that I don't know where to go, to which master node I have to go. And if they are act like a separate entity, it means that the HCD and all those like information will not be synced, and that will cause a lot of problem. So if you've worked on AWS cloud or any cloud, you have heard about load balancer. So there we will be going to use load balancer, and it's not a AWS load balancer. It's one of the well-renowned tool which is HAProxy that will help you for load balancing. Also, you can try load balancer like Nginx Ingress load balancer or F5. But today we will be going to use HAProxy. So for HAProxy, we need a separate EC2 instance, and don't worry, it won't increase a lot of cost because I am keeping things very low, and the cost is also very low of this project, because when I was doing this project, it barely cost me $4 to $5 when I was doing. I don't think so. It took $4 to $5. Maybe it was around $2 to $3 it took, because I was using the different instance type family as well. So I will also show you the hack that, like, a lot of people used to go with simple by default instance type family, but they don't know. Like, I would suggest you, when you're working in your personal project, I would encourage you to go with those types of instance type where you have to pay a very less cost, so you will be able to complete the project as well, and you will be able to save some cost for cloud as well. So as I've told you that we need one more virtual machine, so for that I'll just copy this, and the HAProxy will be in between of worker node and master node, and I will just write it HAProxy. And now let's connect the things to each other. So master 1 will have the connectivity with HAProxy. So I'll just connect this with HAProxy. Then master 2 will also connect with HAProxy. Then the same thing will happen to master 3. Now as now it we can say that if I am reaching out to HAProxy, so it will redirect my request to any of them, because it is now the person who is load balancing my all these things. So now if worker node wants to connect with master node, so he'll just go to the HAProxy, and the same thing will happen to worker node 2 as well. So this way they will be able to communicate. So that's how things will be connected to each other. This is what exactly we will be going to see in this video. But before again jumping to the hands-on, I want to cover few interview questions as well, so you will be able to understand why are you doing that and what is the purpose of it. So we have three master node, and you have heard from a lot of people that they used to say that ideal approach is to have minimum three master node in your Kubernetes cluster. So why they used to say? So let's understand the math behind this as well. One more tool. So let's understand exactly how, as I was saying about the quorums and all those things. So why should we need three Kubernetes cluster? So behind quorum there is a formula which is n by 2, that is in the brackets, and then we will have plus 1. So to find the quorum or minimum value, this is the formula that we use. So we have to understand that how to calculate it. Now what is the meaning of quorum in the Kubernetes cluster? So if you want that your Kubernetes cluster should be highly available, so how many numbers of master node you should have? So with the help of this you would be able to find it. Now the meaning of n here is your number of nodes. So I'll just write it the same thing, that n refers to number of nodes, or you can say master node. So let's try to calculate, because I want you to understand how things works. You just have to keep one thing in your mind, that the result which is coming as quorum slash minimum is that the minimum number of master node there would be running. Okay, so let's understand that I have number of nodes are 2, and then let's try to calculate it. So if I try to calculate like this, so if you are good a little bit with maths, because this is a board math thing that we are doing, so as per the math you can see that the solution of this operation is 2, because 2 divided by 2 is 1, and then we are adding the 1 plus 1 which is 2. So what exactly 2 means? So the 2 means is minimum number of master nodes must be up and running. If you understand this, so here as per this calculation, as we took two number of nodes, we can't tolerate any of the node, because as we have two nodes, so it is saying that the master node should be up and running 2, which is minimum. Okay, but let's suppose if I take number of nodes 3, and let's do the calculation here, like 3 divided by 2 plus 1, so the answer would be 2.5. And now we can round off the 2.5 to 2. So now it is saying then again the master nodes should be up and running 2. So other than that, the node that we have, which is one node, we have already one more node, which means that we can afford the failure of one node at a time. So that's why we need to have three master node at least, and with the help of that our Kubernetes cluster would be highly available. So in today's video we will have three master node. I hope you understand about this thing, and let's try to implement this hands-on. So after theory part, so let's move to the hands-on part. So we would have 6 EC2 instances. Also I will show you the machine type we will be going to use. So I'll just use this. So let's keep this the name of the instance name. Then we will use instance type. So first of all we will have master node, which is master node 1, 2 and 3. So for that we will be going to use T3A.medium, that generates less cost as compared to T2.medium or T3.medium. Then we have worker node. 1 and 2. So for that we will use p3a dot small, and then we will have HAProxy, and for that we will be going to use t3a dot micro. So if you have tried small instances and micro instances, so you know how much cost it takes, and that's why I told you that it won't take a lot of cost while working with this. Do the hands-on. So now let's create the virtual machines according to this specifications. So I'll just go to my AWS console. As you can see, this is my AWS console. So I will click on EC2. I will go to my EC2 instance and let's launch the instance. So first of all, we will be going to create a master node. So for that, I will just provide master node name, and let's keep one for all. And then I will select the Ubuntu. So we will be going to use 24, which is the latest Ubuntu version. Then the instance type that I've told you, which is t3a dot medium. And if there is some issues related to region unavailability of the particular instance type, so I would encourage you to use UST one, because they have the most type of instance type available in the UST one, because have that region is a primary region. So if I just show you the cost of this, so you can see that the T3A medium cost is around, we can see there are multiple types of pricing we can see. So the Linux based pricing is 0.03, and if I go to T3 dot medium only, so then you can see that the base pricing is around 0.04, and now you can say that it's very less. But when your multiple machines are running, if you are choosing the right instance according to your requirement, it will save a lot of cost, because you are not going to create or do the projects only once on AWS. So that's why I'm telling you, you can go with, so that's why, so I'm just using t3a dot medium. Then I will select my key pair. Then after that, you can see that we have networking, and I am not going to select anything, because like things are already fine. If you like, when you are working in the organizations, you should disable the auto assign public, so it will only rely in the private subnet or private network. But for now we are not going to do that, because our aim is to learn how to configure the Kubernetes cluster with high availability. We have already created few of the security groups, but for now I will just click on create security groups, or we can also go with existing security group. So for that, I will just use default security group, that is by default open all the ports, and rest of the things should be as it is. Like we don't need to increase the storage size of the EC2 instance. And now the next thing that we have to create 3 master nodes. So what I'll do, instead of creating the same instance type again and again, I will use this feature, which is number of instances. So I'll provide 3, and now I can click on launch instance. So now we can see that the launch of all 3 instances has been succeeded. Now let's create another 3 EC2 instances, because it will take some time. So this time we will be creating worker nodes. So I'll use worker hyphen node hyphen 1, and I will provide number of instances are 2. Then we will use Ubuntu with the latest version. Then as I've told you that this time we will use t3a dot small. So sometimes it have some issues like lagging, but yes, we have it. Now I will select my key pair, and again I will use the same security group for this, and let's click on launch instance. After creating the worker node instances, we will be going to create one last EC2 instance, which is HAProxy. So for load balancing, we need to create that instance as well. I will give the name to the instance is HAProxy LB, and there would be only one instance for this. You can have more instances as well, because ultimately it's a load balancer, and you should also be want to make it high available, but you don't have to do that for now. And the instance type of this HAProxy instance is t3a.micro. I will select the key pair, and then again I will use the existing security group default, and I'll click on the launch. So after creating all these 6 instances, I will just go to my instance section, and now I can see that the status check is in the initialization mode. So meanwhile, what we can do, we can just provide the correct name to all the instance. So as we know that the name of the master node and worker node needs to be correct. So for that, I'll just provide the numbering. Then for the another master node, I will correct it. Then we will have another worker node. So the naming convention is now correct. And if I just again refresh it, so it should pass few of the checks, but yeah, it's in the progress. But we can try to SSH whether we are able to connect it or not. So I will just click on the connect, and here I can see the SSH, it is showing. And if I go to my terminal, so I will just run this command. Now we can see that it is asking for the fingerprint, and it means that it is working fine. So I'll just use sudo su, and I'll clear the screen. Now we have to SSH in all the 6 instances, including this. So now 5 instances are pending to SSH. So I'll do the SSH one by one. So this is our master node 2. Just provide the prompt. And I will clear the screen. Then we'll SSH into the master node 3. Now we will SSH into worker node. So I'll open another tab. Then we will SSH into the worker node 4. And in the end, we will SSH in our HAProxy server. So I'll just get the command. So now we SSH in all these instances. Now after doing SSH in all the instances, we have to configure our Kubernetes multi-master node. And along with that, we also need to configure our worker node and HAProxy. So for that, we need to run the set of commands. So the command you will be able to find in my blog that I've written on Medium, and you can get the link of that blog from the description. So you don't have to write the command yourself. If you want, you can write it as well, but I will also try to explain what exactly the command is doing. So you will be able to understand what exactly is happening. So let's run those commands. So first of all, as you know that there are 6 instances, and the point is that maybe it would be very messy where you won't be able to understand on which node we are doing what kind of work. So that's why we are going to set up the host name for each node or for each EC2 instance. So we will be able to understand that exactly what is the name of this node, because I know that you can able to find the node name or EC2 machine name using the AWS console, but if you have to check using the CLI, so I want to make it more easy. And also there is one more reason that I will tell you why we are doing this. So let's do that. So as you can see that we are running two commands, in which the first command is to set the host name, and then after that we are updating the packages and we are upgrading it, because that is one of the important thing that you have to do after creating the virtual machine. So I will do that, and it will take some time. So what we will do, we will just run all these commands on all the machines and make sure that you provide the correct host name. So I have just already written the commands. I'm just getting those commands and pasting those commands and running those commands. Okay, so you can see the host name is K8 masters 2. Then I will just get the master 3 command as well. I will paste it here. Then after that we will have worker node, and make sure to log in as a root user, because if you're not logged in as a root user you won't be able to do. Yeah, I've already added sudo command, but somewhere it was not there, like I've not added the sudo command, so that's why ultimately I've logged in as a root user and then I was running the commands without sudo. So I'll run the command on worker node 2 as well, and in the end we will run the command on our HAProxy machine. So if I just go to the master one, it's still downloading, so that's why I told you that uh, run the commands on all the machine to save some time. So now it is getting completed, and yes, we can see that the upgrade activity has been completed on master 1, and yeah, seems like master 2 is also in the process. Now the next thing we will be going to do after this, once the upgrade activity has been completed, we will just exit from this, and then we just do the SSH again. And as you know that if you're on terminal you don't need to write the command again, so you can use up arrow command, so you will be able to enter into the machine. And now you can see that if I'll just zoom in, so you will be able to see that the host name of this machine is K8 master. So now we will be able to understand that this is master node 1. Then after that we have to do the same thing here as well, so this is also master 2 node. Then after that we will do the same thing with master 3. Now the worker node is also working fine, and let's do the same thing with HAProxy as well. So yes, that we have completed this thing. Now the next thing that we have to add the host name of each machine on each node. So let's do that. And don't worry if you're getting confused, as whatever I'm doing before that I'm telling you to understand what exactly we are going to do. So I will again log in as a root user, and there we have host file. And as you can see, so now we have to add the entries for all the 6 machine in all the 6 machines. You have to remember this line. So what I'll do, as you can see that we have the name that we have set, which is HAProxy and all those things. So now we will be going to call them using this host name on this IP. But when I was trying this thing, so these are my old IPs. So what I'll do, I'll just replace them with the new one. So I'll get it from AWS itself. So this is our HAProxy, and we will get the IP for master node 1 as well. Then we have master 2. This is our master 3. Then I'll take the IP of worker node 1 and worker node 2. So now we have all the IPs of for all the machines. So I'll just copy this line as well, because we have to copy this and paste it on all the remaining 5 machines. So I'll just save and exit. Then after that again I will log in here as a root user. I will open the host file. I'll copy this. If you want you can also check by ping the host. So what I'll do, I'll just, before adding all these things on all the servers, we will try to check whether it is working or not. So I'll just use nc-zv command, and this is our IP. Let's try to ping on 22. So you can see that this connection is succeeded. It means that it is working fine. And if I try with, because this is our same machine, so that's why it's working fine. Let's try to do on the different machine. So it's not working. Let's check why it's not working. Because, so yeah, my bad. Actually, the first IP was for HAProxy. If I try with 232, so it should work. Okay, it's not working. No worries. Okay, I'll try with first with the hostname as well. The command is wrong, and port number we have to provide. Okay, so this is working fine. If I just replace the host name, and we can see that it is able to communicate with the worker node 2 as well. Let's try with the 1. So we are able to ping that as well. If you want, you can also use ping-c command, and then you can ping this particular machine. So let's try with master as well. Let's check whether it will try to ping itself or not. And yes, it is able to do that. And we can also see the IPs of all those things. I'm just checking all those things because earlier it was not working, and so I'm just reconfirming all those things. Let's try to ping master 2, and again it's working fine. Master 3 is also working fine, so it means that it's working fine. So I'll just again copy this, and I think we already added in the master 2 node, so I'll just quit it. So yeah, it's broken, so I'll just again SSH, and again I will just open the file etc hosts. Then after that I will add in the worker node as well. So now we are adding on the last server. So I'll save and exit. And after adding this, so we are set to do the next thing, that is we have to install the Kubernetes utilities, where we will have to install kubeadm, kubectl, and kubelet. So let's do that, and those commands will be going to run on only on master and worker nodes only. And this time we will not be running the command on HAProxy, because HAProxy we will use for load balancing. So we will install some other utilities. So let's do that, and I will be going to install the Kubernetes version 1.34. So I'll just go to the first master node, and I'll just again SSH in all those. So I'll just log in as a root user. Now the command we will be going to run is swap off. And if you know that whenever you want to install Kubernetes, so Kubernetes wants you to disable the swap, and along with that it also permanently disable all the swapping by using sysctl parameters as well. So we will be going to run that command, and it won't take that much time, but again I will run these command as soon as possible on all the machines. So I'll just running it on now worker node. So this is completed. Now the next thing that we have to do is we have to install the containerd because this is the recognized container runtime from Kubernetes. So we will be going to do that. And as you can see that it will update few of the repositories, and then it will also install prerequisites that CA certificates, AP transport, HTTPS and all those things. Then it will add the Docker repository, and then ultimately it will install containerd, and it will enable the containerd as well. So I'll just hit enter, and again I will run these commands on all the machines. I've ran these commands on all machines. Let's see the output on this first machine. So we can see that the command runs successfully, and also the master node 1 2 3 completed, and worker node 1 already completed. And yeah, so it seems like the commands run successfully on all the machines. So now we will be going to install kubelet, kubectl and kubeadm utility. So first of all, this is the repository that we are using, and this is the sign by repository that we are using in our keyrings, and then we will install this. Let's see, because sometimes there is some issues when I was doing, so I am expecting that this time it won't give us any issues. So we can see that it worked. So I'll just run these commands on all the machines. So I have ran these commands on all the machines, and we can see that this command is already successful on master node 1, and also it is getting completed on master node 2 and 3. Then yes, we can see that the commands run successfully again on all the machines. And the next thing that we have to do is we have to, so as the Kubernetes installation utility completed, now we will be going to install the HAProxy on the HAProxy machine. So for that I will just show you the command, and this time as you can see that this is the last terminal. From the right we have our HAProxy. So I will just open one more tab or one more terminal, and before running this command I would like to explain you what exactly we are doing. So with this command, which is install HAProxy, we are installing the HAProxy. Then after that we are creating the configuration, and in the HAProxy configuration, which is haproxy.cfg configuration, in that we used to declare, or we used to define the front end and back end. And if you see in the front end, which is Kubernetes front end, it means that HAProxy is saying that I am the front end guy, and then in the backend it is saying that in my back, or like if you talk in terms of technical stack, front end and backend, it means that HAProxy will handle all the requests, and then it will forward to the backend, which is we have master nodes. Okay, so if you see that we have already mentioned the host name when we were doing, I think in the second or third steps after creating virtual machines. So because of that we don't need to change the IP, and that's the main benefit when you are working with the host names. And at that moment you don't have to provide the IP again and again, because we did the same thing only one time. So what I'll do, I'll just run this command, and after that it is restarting and enabling the HAProxy. So what I'll do, I'll just first of all log in the HAProxy machine, and I can check that this is a HAProxy machine. And now I will run this command, and I don't think so it takes a lot of time, because it will complete within 10 to 15 seconds. Yeah, as you can see that it is getting completed. Now we can see that it is saying backend Kubernetes server, it does not have any server available. Now the reason is that because there is no cluster available right now, or there is no master node available. Okay, and also why is the reason? So if I just show you again the command that we run, that the server K8 master 1, and then the machine host name, which is IP colon 6443. So if you know, Kubernetes have one component that runs on 6443, which is Kube API server. So let's go to our that machine master node 1. Let's try to see the ports that currently present. So what I'll do, I'll just run this command, and you can see that there are only few ports open right now, or you can say that few services are only running, and in which there is one 40,103 22 for SSH and 53 for DNS. And right now it does not running any specific process that contains 6443 port. That's why it is showing backend Kubernetes has no server available. So for that, it's a expected error. And the next thing that we have to do is that we have to generate the kubeadm config file, and with the help of that kube config file we will be going to initialize the kubeadm command. So it will create the Kubernetes nodes, or you can say that it will deploy the Kubernetes cluster that we are looking for it. So let's do that. And again, I have some more changes, but let's do that thing first. So as you can see that we are running this command on our master one, and it is saying that cat, or end of the file, that it is saying that cat, and all the content we can see here, which is API version kubeadm.k8s.io. Then it also have the init configuration and the cluster configuration resources it is creating, and all the configurations will be written in the kubeadm file. So we are not applying it right now, we are just saving the configuration, and then with the help of this configuration we will run the kubeadm command. And as you can see that we need to make some changes. So what I'll do, I'll just enter, and let's see the whether the file is present or not. So we can see that kubeadm file is present, and as we can see that the content is written. Now the point is that we have to change few things, in which the first thing that we have to change is control plane endpoint. Then after that we have to change the advertise address as well. Now why the advertise address we have to change? So now why, so if you have seen, like, there are two different IPs. The first is control plane endpoint, and the second thing is local API endpoint. So the first is local API endpoint, which means that it is referring to itself, which is Kubernetes master node IP, which is we have to change it to our current master node first IP. Then the second thing is control plane endpoint. Now control plane endpoint means that it will saying that it is referring to the HAProxy IP. So if you're keeping the both the IPs same, so it means that there is only one master node, and if someone wants to connect with that to master node, it will come using control plane endpoint. Okay, so that's the reason. So what I'll do, I will update this kubeadm file. So I'll just remove this IP. Then I will get the HAProxy private IP. Then after that, we will be going to provide the Kubernetes master one node IP. So I'll just get the master node one IP as well. And all set. And now we will be going to save this file. And now we are ready to initialize our Kubernetes cluster. So for that, we will run this command, which is kubeadm init. And in that, we are providing the config file that we just updated. And after that, it will also upload the certificate as well. So let's run this command and let's see what exactly it does, and then we will also see the output. So I'll just hit enter, and it will take some time. And also you can see few other things, like that is detected, that's the sandbox image we are using of the container runtime is inconsistent with that used by kubeadm, and it is saying that it is recommended to go with like 3.10.1 version. So there is some version change, and after that we can see that it is started like generating CA certificates and all those, because we know that Kubernetes have multiple components and they created the certificate for each component, so they will be able to authenticate to themselves. Then after that it started creating static pods, which is kube API server, control manager, kube scheduler. Then after that it is checking the health using /lives, and then it is checking the health check of control manager scheduler as well. After this, you can see that upload config. Now it is storing the configuration used in config map. As you know that once you configure a Kubernetes cluster using kubeadm, so it will create a kube config map. So it is doing that thing. And then after that, it is using the certificate, and like RBAC rules and all the default things has been configured, and in the end it is saying that also applied core DNS and QProxy, and the Kubernetes control plane has been initialized successfully. Now to start using your cluster, you need to run the following as a regular user. So we have to run these commands. Okay, then after that, alternatively, we can also use, if we are a root user, we can also use this, like this command. But I would suggest you, if you want to run your kubectl commands using non-root user, so just follow this instead of this, because after running like these three commands, if you run export as well, so it means that it will refer to the adm.conf file as well, and ultimately you won't be able to run kubectl commands with non-root user. So I will encourage you, either you can choose this or only choose this. Okay, then after that you should now deploy a pod network to the cluster, and let's see, like that we will see, because we will be going to see one error or some issues. Then after that, we can see one output, which is you can now join any number of control plane nodes running the following command on each as root. So it is saying that we can invite any machine to be a master node along with us, or along with master node 1, and this is the command that we can use to do that. Then after that, please note that the certificate gives access to cluster sensitive data. Keep it secret. As we know that these are the tokens and certificate. It is secure and it is very confidential. So you make sure that you should not share with someone else. Then after inviting a machine to be a master node, you can also configure the worker node. So we are inviting a particular machine to be a worker node. So we can schedule our nodes on that worker node as well, on that machine. What we will be going to do, first of all, I'll just run this command, and this. Now what I'll do, I'll just run the kubectl get nodes command, and I can see that the age around 3 minute 45 seconds and it is not in ready state. That's fine, because it is expected. Now the next thing that we have to do, that we have to invite the other two machines to become a master node along with this. So what I'll do, I'll just copy this and I'll again do the SSH, and as it said that we have to do it as a root user, so we have to become a root user. I'll just copy this, and as we have copied these things, it will also take some time, and I will run the same command here as well. It is deploying the things, and we can see that there are few things. It will give you some issues like endpoints, all those things it will show you, and after that you can see that it is saying that the node has joined the cluster and a new control plane instance was created, and a new etcd member was added to the local slash stacked etcd cluster. So etcd is a different topic, because it takes, kind of a master class when you're working with etcd, because you need to know how to back up the etcd, because that is one of the important thing in kubernetes. Like the reason is that it stores all the data, whatever you're creating the pods or all the information it has. So you should, create the backups of the etcd on a regular basis. So that is, and currently it is storing all the information on the local machine. So that's why we have to do that thing as well. But for now it is very basic thing that we are doing. So I will run these command as well again, and we can see that the same thing here we have to do. So now if I just go to the master node 1, so I'll run the kubectl get nodes command. So this time we will be able to see we have three master node, but currently they are separate entity. But how we will balance the load? Now for that, earlier you were seeing the error in the HAProxy server that has, like, backend Kubernetes has no server available. So this time what we will do, we will just restart the HAProxy, and let's try whether we will be able to see the same error again or not. So I'll just do sudo su, and I'll just get the command again, and I will restart the HAProxy and then enable it. So now you can see that it is restarting, and if we will try to run the nc command with -z, and if I try to ping the machine, so let's try to do that. We can see this is succeeded because now the ports are running on 6443, and we can also run the command, and now you can see there are plenty of ports. We can see like 2379 for our HCD, like same with 80. Then we have like 2381, 2379 again. Then we have 10249 for kubeproxy. Then like 40103 was for container D. We can also see the process. And then for kubelet it is using 10248. Then for kube controller it is using 10257, then 259 for kube scheduler, and the main thing 6443 for kube API server. So it means that it is working now, and HAProxy is also able to handle the traffic as well. So that is completed. Now the next thing that we have to do, that we have to join the worker node in the Kubernetes cluster. So I'll just first of all log in both the instances, and as we had commands, so I'll just copy this command. So let me tell you one more thing also, like as we have seen that certificate key and all those things, if you're thinking that you can keep these two commands in your notepad, and if you're trying to run these commands after 1 hour or like after 1 day or 2 days, it won't work, because you know that Kubernetes cluster, like this, it will delete the certificates after each 2 hours, right? So that's why there is no use if you're thinking that you can keep these commands. So I'm just telling you for a interview perspective that how things works, so you can explain these things, how Kubernetes handles certificates for their own to bootstrap particular nodes. So what I'll do, I'll just this is again HAProxy, so I will just run sudo su. As we can see that it is successful, and as we can see that it is saying that run kubectl get nodes on the control plane to see the node join cluster. So what I'll do, I'll just run the same command again as well here, then we will see the nodes in one go. So yeah, it is also taking time, and now it is working fine, and I'll just come on my master node, and what I'll do, I'll just run kubectl get nodes, and we can see that now we have 3 master and 2 worker nodes. So yeah, like the configuration of the multi-master node is finally done, but the main issue that the status of all nodes are not in ready state, it's because that we did not deploy our CNI, which is container network interface, and for that we will be going to deploy our CNI, which is we will be going to deploy Calico. So let's do that thing as well. So this time we don't have to deploy, like we don't have to run these Calico command or kube apply command on every node, because now it's kind of a one entity where if you run a particular command it will work on all machines, because it's a Kubernetes cluster, right? So I'll just hit enter, and as you can see there are a lot of resources creating, and ultimately it is also creating deployment sets and daemon sets. So what I will do, I'll just run the kubectl get nodes, and we can see that the worker nodes now are coming in the ready state, and also we will see master nodes will be in ready state within few seconds. And yes, we can see that all the nodes are in ready status. So that's amazing. And if I want to check the pods, so I can also check the pods, and we can see the pods, like this is a Calico pod that is there, then this is a HCD pod, all those things are there. So yeah, this is it, and we are able to achieve the high availability. Now let's try this high availability, whether we will be able to work or not. So what I'll do, I'll just do one thing, which is kubectl get nodes. So as we can see that we have 5 nodes. So let's try to shut down one particular master node, then let's see what it does. Okay, so again I'll log in, I'll SSH into the machine, and what I'll do, I'll just become a root user, and we will run the command. To test this, we have to shut down a particular node, or we have to delete a particular node, right? But instead of deleting it, I will just shut down this particular node. So what I'll do, I'll just run this command shutdown -h now. So we are saying that shut down this machine for now. So if I just do it, so you can see that the system power will off now. and we can see that the connection has been disconnected. And if I run the kubectl get nodes, it will still show me this as a ready state because it takes some time, because the reason is that threshold, like it sets a particular threshold. So if you can see that still the, like we run the command on our master 3, so the master 3 should be in the not ready state. Currently it's not showing. The reason is that it also sets the failure threshold, like 5 times or 10 times it will send the same check, like it will send the same hit to check the API whether it is live or not, kind of a readiness probe or liveness probe, right? So that's why it takes some time. And if we check, so you can see that this, the master node is not in ready state, right? And that is what we have achieved. And point is that if you're able to see this output as well, it means that things are working fine and your cluster is highly available. Because if your cluster is not highly available, so you won't be able to see the output, and maybe you will see that connection timed out, and I will show you that thing as well. But for now, I will just run one application. I'll just run kubectl run, and let's provide the name of the pod is nginx, and I will provide the name of the pod is, I will provide the image as nginx, and we can see that there is one pod created with the name of nginx. We can say that it is creating the container, like the container is getting created. Let's see again, and now we can see that the pod is up and running. And if I again check the nodes, so the master 3 is in the not ready state. Now this time we will shut down this machine which is master 2, or let's try to shut down. Okay, so one thing, let's try to do one thing. What I'll do, I'll just run the kubectl commands from master nodes, and as you know that we have to become a root user to do this. So you can see that we are also able to run the kubectl commands from our any of the master node. You can run these commands. So we will shut down master 1 node and let's see what will happen. So I'll just run the shutdown -h and then now, and again it will take some time. And also let's check our pod whether it is running or not. Yes, it's running. And I'll just clear the screen so we would be able to see. And now as soon as I run the command get nodes, you can see it is not able to respond me. And that I was talking about the quorum thing, that it is saying that unable to connect to the server. So as I've told you, when we have two master nodes up and running, so there is no fault tolerance, and it won't provide you the output whatever you're looking for it while running the kubectl commands. Currently you are able to see the error which is unable to connect to the server, but after some time you will be able to see the administrator role error as well, where like it will say that okay, you are not a correct person to run these commands, like cluster rules and all those things, RBAC things. That's why, that's the main purpose to have three master nodes whenever, like how much master nodes should be there ideally, or minimum master nodes. So it should be three master nodes. So let's try to again run, because this time you can see in the second, you can see the error was the server was unable to return a response in the time allotted. So it was kind of a timed out. Then the next thing, you can see that error from server forbidden. Now it's related to your access. So user Kubernetes admin cannot list resources nodes in API group at the cluster scope. So I will just, let's go to my browser and I'll just refresh it. I'll hit on the refresh because right now you can see that all the machines are up and running. And if I just click on the refresh, you will see that there would be two machines are stopped. And yes, we can see that. So what I'll do, I'll just, let's up the machine master node 3. And what I'll do, I'll just click on the start instance. After starting it, let's get back to the terminal again. Let's try to run the kubectl get commands. Okay, and again the machine is coming up. It will take some time, like few seconds it will take. So let's try to run this command again and again. So now you can see that as soon as I've run the command kubectl get pods, it is able to provide me the output. So what I'll do, I'll just first of all check the pods of all the nodes, And if I go to the HCD, so you can see that HCD of all this are working fine, and few of the nodes you can see are restarted, which is master 3. Then you can see the API server of two machines of or two master nodes have been restarted, and the same thing with master 2 and master 3. So that's it for this video. I hope you learned something new, and my intention was to explain you or show you the hands-on that how to configure the highly available Kubernetes cluster, because it's easy to configure a single master, but when you start working in the industry, they will ask you to configure the Kubernetes cluster with high availability, or they will go with the EKS or AKS cluster. But so if you're thinking that EKS or AKS knowing is enough, I would say that no, because you need to understand the baseline, like how things works behind the scene. I hope you liked it, and let me know in the comment section if you're working in an organization, so how many Kubernetes clusters or how many Kubernetes master nodes you do have for your Kubernetes cluster. And if you have any suggestions, feel free to drop in the comments. If you want to reach out to me, you can reach out to me on LinkedIn. And if you have completed this hands-on or any other project, so you can feel free to tag me over LinkedIn. So I would be happy to see your progress. And it's very important as a fresher or as an intermediate learner to show things on the LinkedIn, because it's very important in today's time that other people can also learn from you, and it will help you to grow your network as well. And after that, like if you have any issues or if you're stuck somewhere while doing this hands-on or any other hands-on, feel free to reach out to me on Discord. So for that we have community which is Opstock, so you can reach out to us. So I'll provide the link of this community in the description. You can feel free to join us and just share your learnings. If you have something, let me know. Whatever the suggestions, I will try my best to create the guide or hands-on, because my aim is to go with the practical thing instead of theory. So because while doing practical, you will also learn a lot about theory as well. And that is for the today's video. I will meet you in the next video. Have a good day.